A plane is falling from the sky, not a small one. A commercial jet, 400 people inside, engines dead. The nose tilting down, the ground rushing up. On the streets below, people stop. They look up. Some take out their phones, some just freeze. And then, in a streak of red and blue, he's there in less than a second, arms out, hands pressed against the belly of the aircraft. The plane groans. The crowd holds its breath. And then, it stops, hovering safe. A man in a cape has just caught a falling jumbo jet. The crowd erupts, but here's what nobody in that crowd is thinking about. The passengers inside, the 400 people Superman just saved, they were still traveling at over 300 kilometers per hour when he grabbed that plane. Their seats stopped. The aircraft stopped. But their bodies, their internal organs, their bones, physics doesn't stop just because Superman showed up. So before we celebrate that rescue, before we call it a victory, we need to ask a question that comic books never really answer. Could Superman actually survive the laws of our universe? And more importantly, could we survive him? Let's stay with that plane for a moment, because what happens next is the part nobody talks about. Superman catches the jet, the aircraft stops, but inside, 400 people were still moving at 300 kilometers per hour, forward toward the seats in front of them, toward the cockpit, toward each other. Think about it this way. You're in a car going 60 kilometers per hour. The car hits a wall and stops instantly. Your body, keep going at 60. That's why seatbelts exist. That's why airbags were invented. Your body doesn't stop when the car stops. Now multiply that by 5. Engineers have a name for this problem. They call it impulse, the relationship between force and time. The faster you bring something to a stop, the more violent the force is on everything inside it. And Superman's catch? That's one of the fastest possible stops. The way to save a falling object without destroying its contents is to slow it down gradually. Match its speed first, move with it, then guide it gently to a stop over several seconds, not catch it, cradle it. That's a very different image from the dramatic one-handed saves we see on screen, but it's the one where people survive. And now think about a person. Someone falls from a skyscraper. Superman dives, catches them around the waist just before they hit the ground. Heroic moment, crowd cheers, except the person was accelerating downward at full speed. Superman catches them. The bottom half of their body stops, the top half keeps going. The comic books actually dealt with this once. Famously, in a 1971 story, a character dies not from falling, but from the sudden stop. The whiplash itself is fatal. Superman's strength doesn't make this problem easier. It makes it worse. The stronger his grip, the more force concentrated on a small area of a human body. A grip powerful enough to hold an airplane could, at the wrong angle, cause catastrophic injury, not through cruelty, not through carelessness, just through physics. Every rescue is a calculation. Every catch is a risk. The hero with the most power has to be the one with the most precision. But wait, let's back up, because before Superman can catch anything, he has to get there. This is the power that defines him, the one we picture most. In Man of Steel, we see him hovering above the clouds. In the classic films, he races beside fighter jets, banking and turning without engines, without wings, without any visible means of propulsion. He just goes, and when you think about it for more than a few seconds, this becomes very strange. Flight requires something to push against. A bird's wings push against air. A rocket pushes against its own exhaust. A helicopter pushes air downward to rise. Every flying machine ever built works the same way. You push in one direction and the world pushes back. That's Newton's third law. For every action, there's an equal and opposite reaction. So what is Superman pushing against? There's no exhaust trail, no visible downwash, no air displaced in a way that explains his speed or his lift. Some physicists have suggested Superman might generate and control his own gravitational field. Instead of falling toward Earth, he essentially chooses what to fall toward. He reshapes gravity around himself. That sounds wild, but it's actually one of the more physically coherent ideas, and here's the unexpected side effect. If he's generating a gravitational field, everything near him is affected too. Fly over a crowd at full speed and loose objects, bags, phones, even people, might experience a sudden invisible tug in his direction. A superhero who flies might occasionally behave like a very localized, very confusing magnet. But the bigger problem is speed. When Superman races beside those fighter jets, he's moving at or beyond the speed of sound, around 1,200 kilometers per hour at minimum. And breaking the sound barrier isn't just loud, it's violent. The pressure wave that builds when something travels faster than sound has to go somewhere. It radiates outward as a shockwave. Aircraft are banned from breaking the sound barrier over populated areas for exactly this reason. The pressure wave shatters windows, disrupts structures, and can knock people off their feet. Superman flying over a city at full speed isn't just impressive. Every supersonic pass is a small disaster. The skies over Metropolis must be exhausting. Remember the final battle in Man of Steel? Superman and Zod crash through skyscrapers. They slam each other through train stations. They punch each other across entire city blocks. Buildings crumble. Glass fills the sky. The camera shakes with every impact. In the theater, it looked spectacular. But if physics had been invited to that fight, Metropolis wasn't experiencing a superhero battle. It was experiencing an extinction-level disaster, and the strangest part, the buildings weren't even the problem. Now, what happens to the air? At sufficient force, and we're talking about a man who stops freight trains with his hands, a punch doesn't just hit the target. It creates a pressure wave through the air around it. A shockwave that radiates outward in all directions from the point of impact. We've seen this in military testing. Even non-nuclear explosions create blast waves powerful enough to shatter glass hundreds of meters away. Not through fire or heat, but purely through a sudden change in air pressure. A Superman punch? The force involved would be so far beyond anything in military testing that the shockwave would effectively behave like a localized explosion at street level. Every window on the block would shatter instantly, not from debris, from pressure alone. People standing nearby would be thrown off their feet. Awnings ripped from buildings, parked cars flipped. Superman punches a villain in downtown Metropolis. The villain takes the hit, and 3 city blocks full of bystanders get knocked flat. He wins the fight, he loses the neighborhood. The heroes in comic books almost never show us what happens to the people standing 50 meters away when 2 superpowered beings trade blows. But physics doesn't forget them, and this becomes even more alarming when you consider heat vision. In countless comic panels and films, we see Superman slice through steel doors, weld structures from a distance, or stop enemies in their tracks with beams of intense heat from his eyes at the temperatures those beams would need to reach to cut through steel. We're talking thousands of degrees. The air itself would change. The nitrogen and oxygen in the atmosphere would begin to break apart into their individual atoms. At even higher temperatures, electrons separate entirely. Air transforms into plasma. Superman firing heat vision across a room wouldn't just heat the target, he'd be drawing a line of superheated plasma between his eyes and whatever he was aiming at. Everything in that path, on the air, any objects nearby, anyone standing in the wrong place would be affected. His most cinematic powers are, in physical terms, some of his most dangerous ones. Not to Superman, to everyone around him. Picture this, a skyscraper is coming down. You've seen it in the films. The structure buckles, the floors begin to pancake, and Superman is suddenly there, hands pressed against the side of the building, holding it up. Thousands of people inside. The crowd below gasps. He holds. The building stops. It's one of the most iconic images in superhero history. But what if the building Superman just saved couldn't survive being saved? A standard office building weighs somewhere around 50,000 tons, and Superman, in that classic pose, presses his hands against the exterior and lifts. Here's the first problem. The building itself. Concrete and steel are strong, but only in the right conditions. Buildings are designed for their weight to travel downward, distributed evenly through columns and beams into foundations. Lift a building from any single point, and you're concentrating enormous force in a place the structure was never designed to handle. The building might simply fold, crack at the base, come apart from the inside. Superman's strength isn't the limiting factor. The structural integrity of everything around him is. The same problem applies to trains. A train is a long chain of connected cars. Grab the middle to stop it, and you might just snap it into 2 sections. The front stops, the back keeps going. But the deepest problem is the ground under Superman's feet. A normal person puts a few kilograms of pressure per square centimeter on the ground when they stand. Now imagine Superman lifting 50,000 tons while standing on a city street. That enormous force travels down through his body through his boots, which have the surface area of human feet, and into the pavement below. The pressure per square centimeter would be extraordinary. He wouldn't just stand there. He'd punch through the pavement, through the concrete, into the soil, possibly into whatever infrastructure exists underground. Water mains, gas lines, subway tunnels. The strongest man in the world might accidentally bring down the city infrastructure every time he saves a building. One possible solution: Superman doesn't fully stand when he lifts. He hovers just centimeters above the ground, using that same gravitational manipulation from before. That would distribute the force differently, might even make the physics work. But then we're back to the question from section 2. What exactly is he pushing against? Up until now, we've been asking whether Superman could save individual people. But what if the biggest thing Superman breaks isn't physics? What if it's civilization itself? Let's zoom out now. Past individual rescues, past single punches and catches. What happens to a civilization that contains Superman? Superman start with the sonic booms. Every time Superman moves at full speed through populated airspace, he creates a shockwave. Not occasionally, or every single time. He doesn't file flight plans. He responds to emergencies wherever they happen. That means random, unpredictable sonic events over cities, suburbs, neighborhoods. His arrivals from space, like we see when he returns from orbit, would generate enormous friction heat against the atmosphere, visible for hundreds of kilometers as a streak of light, and then he descends, lands on a city street. Even a careful landing from high altitude creates a pressure burst on arrival. A downrush of air powerful enough to scatter crowds, topple displays, shatter storefront windows. Every Superman landing is a micro-weather event. Then there's the political reality. Imagine waking up tomorrow and learning that one person or one individual could end any war on Earth before breakfast, could reach any capital city in minutes, could not be stopped by any weapon ever built. How do you feel? Safe or terrified? Because every government on Earth would ask exactly that question, and most of them would land on terrified. Not because Superman is a threat, but because he could be, because he exists entirely outside every military treaty, every international agreement, every system of mutual accountability that human civilization has built over centuries. No army can stop him, no government can compel him. His values seem good, but they're his values, not a treaty, not a law. Every military doctrine written since the invention of gunpowder would suddenly be obsolete, every alliance renegotiated, every arms treaty irrelevant. A single person, one individual, can now override any of it. Superman wouldn't have to do anything threatening for this to happen. Just existing would be enough to reshape civilization. Every summit, every arms negotiation, every alliance would be shadowed by one question: whose side is he on today? The world doesn't get destroyed by Superman, but it never goes back to what it was before him. And now the hardest question, the one that doesn't have a physics answer. If almost every major use of Superman's powers carries unintended consequences, if his catches risk killing the people he saves, if his punches damage the neighborhoods he's protecting, if his landings disrupt the world around him, if his very existence reshapes global politics, can he still function as a hero? Yes. But it changes what heroism means. A surgeon doesn't just need steady hands, they need to know exactly where to cut, at what depth, with what pressure, for what duration. Because the margin between saving someone and harming them is very small, the knowledge matters as much as the ability. Superman's margin is even smaller. And the speed of his decisions is faster. Every rescue is a physics problem. Every intervention is a calculation. How much force, from what angle, over what distance? What's in the path of the shockwave? Who's standing nearby? He has to get all of this right. In fractions of a second, so the rescue becomes something else. That requires not just power, it requires a level of awareness, restraint, and precision that might be more extraordinary than the power itself. A wrecking ball has force, a laser has precision. Superman needs to be both simultaneously every time, and he can't stop. He can't take a day off from being careful. Because the cost of a Superman mistake isn't a bruised knee or a broken window. It's a city block, it's 400 passengers, it's a neighborhood flattened by a shockwave. The comics show us this if you look closely enough. He doesn't just hit things, he measures himself. He holds back, he slows down near people, he chooses angles that protect bystanders. In the films, we sometimes see the strain of that restraint on his face, but not the strain of effort, but the strain of control. Maybe that's what we've been watching all along. Not a power fantasy, something more interesting. A man who could level a continent choosing in every moment not to. So, could Superman survive real physics? Partially, inconsistently. With consequences the stories prefer to leave off screen, but here's the thing. After everything we've just explored, the impulse problem, the shockwaves, the infrastructure failures, the political crisis that arrives the moment he does. The real miracle was never that Superman could stop a falling plane. The miracle was that he knew exactly how, because every person Superman saves is made of things that break. Bones break, buildings break, civilizations break. And somehow, the one thing that never does is his decision to care. That he knew the difference between catching and cradling, between punching and precision, between saving a building and destroying it from the inside. That somewhere in the fractions of a second between arriving and acting, he calculated everything we just spent 17 minutes trying to understand. Maybe the most unrealistic part of Superman isn't that he can fly, it's that someone with that much power could use it so precisely, so thoughtfully, so gently, because surviving real physics might be hard. But remaining a hero in spite of it, choosing care over capability, restraint over force every single time, that might be the truly impossible part. And somehow, impossibly, he keeps doing it anyway.